Welcome back to Software Engineering 1. Today what we're going to talk about is Agile software development as kind of a riposte or a strongly worded response letter to Waterfall. So last time we talked about Waterfall as a kind of early methodology that was used for software development by software engineers, and it's got one really big problem, and that's that it's extremely rigid. So Waterfall was originally intended to be used in kind of adjacent fields like mechanical engineering or construction, where the sequence of steps inside of a project are much more rigid than they are in software, and so ergo the kind of problem that we have. So in a scenario like software development, change is kind of constant. The client can change their mind any number of times a day or a week. And so the rigid process of actually trying to acquire requirements up front and then mitigate any changes to those requirements through the entire life cycle of the development effort is just not really the most efficient thing to do. So it turns out that at this point, fairly old report from 1995 indicated that Waterfall kind of fell short of most of its core goals. And so in the software projects that they looked at, almost a third of them were canceled. More than half of them were completed, but they were completed under a lot of duress. And approximately 16%, so significantly less than a quarter of them, were actually what they considered to be successful. So if you look at other research on specifically the volatility of requirements, it turns out that approximately 30% of requirements actually change through the development of an individual project. And this is assuming that you can get requirements written down on paper from a client in the first place, which is not always true. So the natural sort of outcome of all of these things are called project overages. And so basically what happens is an overage occurs anytime you're using more resources than you have allocated for a project. So you can have time overages or you can have cost overages, where either you are spending too much time or too much money, respectively, on a project. And what happens is in either of these cases, the client ultimately gets upset. Like we talked about last time, the organization takes a loss, potentially on revenue that it could have otherwise collected, or credibility with that client, because the client can blame the software organization for not being clairvoyant in a lot of cases, or it could just be kind of a marketing loss. You could lose relationships. Basically, everyone has a bad day anytime there's a massive overage, and so you want to keep these overages from happening as much as possible. So the first major question we want to ask ourselves in the sort of pursuit of software engineering as a discipline is, how do we get rid of these overages that cause so many problems? And really, if you think about it, there are two ways to do that. Either we have to build a more efficient process for doing our work, or we have to get better at realizing what the actual costs are going to be. So if we are married to Waterfall and we have to use Waterfall forever, we could obviously get very, very good at baking in time to redo whole projects into the real cost. So if you anticipate the cost to be $20,000 and you think potentially you're going to have to rewrite the program 5 times, then potentially you would tell the client $100,000. Maybe you only have to do it 4 times and you come under budget, even though the real cost is extremely inflated. We can really approach the problem from either of these perspectives. Today what we're going to do is we're going to talk about the first one, building a more efficient process. We're going to talk about the second one later on in the class, actually trying to get better at real estimation. So the entire concept of Agile comes out of the idea that Waterfall is definitely a suboptimal way of living your life. and it is not going to, in a lot of ways, lead to a result that either the client or the software organization wants to deal with. So rather than resisting changes to requirements like Waterfall does, what Agile does is embrace those changes. So Agile as a general methodology is predicated on the idea that change is a normal, sort of expected part of the software development process. And anytime a change request is entered by a client, that isn't necessarily cause for alarm. It's cause for understanding the risk associated with that change and trying to mitigate that risk as much as possible, while also incorporating that change into the design or into the implementation as it's currently being done. So each of the core concepts come from this thing called the Agile Manifesto. You would think that that's an extremely lengthy document. It isn't. You can download these lecture slides. You can click on this link and it will take you to the actual manifesto. You can read it in approximately 90 seconds. And a lot of it is going to seem very familiar to you if you have ever had an internship where they practice Scrum, or if you have kind of yourself had the thought experiment around how you might deal with issues that would arise from using Waterfall. So basically, it all boils down to having these sequential project phases, but taking an incremental approach to those phases. So instead of having these very rigid dependencies between phases, what we're going to do is we're going to allow phases to be interrupted by newly acquired information and jump back to a previous phase for a specific component whenever we need to. So we don't necessarily have to restart the whole development of the application. Potentially, we do need to restart the development of a small piece of the application, as long as we can kind of confine the change to one of these components and not the entire system itself. So this entire concept is based on the idea of incrementation and iteration. Basically, every component inside of a system undergoes the same major milestones in the process. Every component goes through requirements gathering, every component goes through analysis and design and implementation and testing. And each of these are ideas that we're going to spend a fairly large amount of detail on. And in fact, we spend about a week on each of those major milestones in the course. So we're going to beat those things to death very shortly. But for now, we're just going to kind of accept that they exist. So as components go through these major milestones, they are created, they are updated as changes occur, as bugs are found, as maintenance is done. And each of these things undergo two major processes. The first one is an incrementation. So incrementations actually represent self-contained groups of functionality. An incrementation could be something as concrete as a class. It could be a group of classes. Basically, it's a new component that's being added to the system that was not previously there. And an iteration refines that increment. Iterations, you can think of those as versions or releases. They're just internal to the company. So throughout iteration, you take an incrementation and you make it better and better and better until ultimately at the final iteration, you hope that incrementation represents exactly what the client expected in terms of functionality. So we might have something that looks like this. We have incrementation A that represents the login to our website. This is a fairly fundamental thing, and so we might start on this very early in the process, followed by incrementation B, which is the sort of main menu. If you're coding a game or something like that, you would have settings, you have starting the game, etc. And then you might also have user management for something like an ERP or a banking system or something like that. Each of these increments are an organized unit of work. They're code that may contain multiple classes, but they encapsulate a single concept. And so each of these pieces of work are going to go through refinement. They're each going to go through iterations. They're each going to encounter all of the sort of major milestones of software development. You're going to have pitfalls in each of them. You're going to have slight changes to requirements in each of them that require you to go back and sort of revisit design or revisit analysis potentially. But ultimately, what you're going to have is, if you look at a time slice at time t of your project, you might have these three completely different implementations or incrementations at various iterations. So you might be on your seventh iteration of the login screen after some severe testing by your testers and by the client, while you're only on the very first iteration of user management, because in order to get through user management, potentially you had to have the login code already done. So what this is showing is that instead of having all of this stuff sort of work at the same level with Waterfall, what we're actually doing is we're allowing all of these incrementations to happen in a staged kind of way. And if there is a change in the main menu, we can always go back to a previous milestone in the next iteration of the main menu and take whatever changes rise into consideration. So it turns out that there's not really anything wrong inherently with what Waterfall is trying to achieve. All of the stages make total sense. You're trying to go from an idea or a concept that's written on a piece of paper to a piece of software that somebody's actually launching at their desktop and using to perform some business function. The problem with Waterfall is that there's this kind of artificial rigid dependency between those stages that says, if something happens during implementation that changes even a very slight part of the analysis or changes a single requirement in a kind of obtuse way, then we have to kind of scrap everything and go back to the beginning and kind of redo a bunch of stuff. So instead of doing that, what Agile does is it takes all of these stages and it applies them component-wise, so that if you have a setback, or if you have a new requirement, or if you have a requirement change, even if that requirement change is fairly drastic, the impact is isolated to a single component where possible, and the impact doesn't ripple all through the entire project. You still have stuff that you can work on. You still have stuff that is completed even after the effects of the change are taken into consideration. So these stages of development, or these major milestones, are requirements gathering, where you basically go to the client and you understand exactly what it is you're trying to build. Analysis, where you try to understand what the existing functionality of the system is. You try to build a technical specification that sort of reflects what the requirements the client asked for are. You go into design, where you actually put an internal facing specification together that kind of puts together the how you're going to solve the client's problems. Then you go into implementation, where you actually perform the coding, into testing, where you actually verify that your coding is correct, and then into support and maintenance, where you basically perform any bug fixing, feature enhancements, things like that that are requested by the client. And so these are the stages of development, or the milestones that we were talking about, that occur for each of these components. Even if it's a very small widget, a button, you have to have requirements for what that button is going to do. You have to understand how that button fits into the overall system. You have to design a way of implementing the button. You have to implement the button. You have to test the button, and you have to maintain that button going forward, even if it's 15 years after the button was initially actually put there. So Agile development at its core is staged on the idea that if you encounter some sort of groundbreaking, earth-shifting change in a requirement during implementation, you can always go back to requirements gathering for that component and then step through these milestones again in order to refine the component for the next iteration. So if you find a new requirement for a component at iteration 1, iteration 2 can always go back to analysis or go back to requirements gathering, and in the next iteration actually propose a fix or propose a better version of that software component. So what we see here is that Agile allows us to perform software development asynchronously. We can do various components at various speeds, and we can account for various levels of complexity, various levels of volatility in each of those components. Using the same sort of milestones, the same stages from Waterfall, we're just applying them in a slightly different way. So one of the things that you're going to find out very quickly in the class is that software engineering, sort of like artificial intelligence, has an obnoxious number of buzzwords associated with it. So one of the things that can really muddy the water are these buzzwords that make it unclear what somebody is actually trying to communicate about software engineering. So over the years, there have been many different pre-baked kind of frameworks that present these concrete ways of implementing specific Agile processes. You might have heard of things like extreme programming or Scrum or Kanban. Some of the older ones are Crystal or dynamic systems development processes. Basically, what I'm using here is the word framework to represent an ideology that concretely gives you steps that, when once implemented, give you an agile methodology for software development. So a lot of people confuse Scrum meetings with the concept of Scrum as a framework, which is sort of counterproductive to the entire idea of a framework. And so that's what we're going to try to focus on for the remainder of this lecture. And so all of this kind of framework mentality began in earnest with something called extreme programming. So this is one of the very first frameworks that kind of took hold and, for lack of a better word, sort of went viral. And so there was a lot of excitement around engineering practices applied to software engineering, particularly these extreme programming concepts like pair programming, where two programmers, hopefully one of more experience and one with less experience, would be paired up to solve a problem as a way of cross-training, but also a way of making sure that developers weren't making careless errors when they were trying to do kind of menial tasks by themselves. Also ideas like refactoring, where you take an existing piece of code and you write it in a better way. So even though you aren't necessarily refining the program's ability to do something, you are refining its actual implementation of how it's performing the task. Or things like continuous integration, where you take everybody's code at the end of the day, or maybe multiple times a day, and you integrate it into one branch to make sure that there are no breaking changes, or at least minimal breaking changes, where people aren't stepping all over each other. And so this went on for quite a long time. People were quite happy with it. And even when I was in grad school several years ago, this was kind of the de facto idea. But in a 2015 survey, a kind of annual State of Agile survey, that survey response indicated that less than 1% of the teams that took the survey were actually using something that they referred to as extreme programming. Now, that isn't to say that extreme programming died. What it means is that people were actually using components of extreme programming without actually calling it extreme programming, which kind of reinforces my point about buzzwords. Just because you have a spoon and you call it a fork, that doesn't necessarily make your spoon into a fork. And so just because people weren't calling what they were doing extreme programming doesn't make it not extreme programming. People are still using pair programming, they're still using refactoring, they're still using continuous integration, they're just using it potentially in a different configuration, or they're using it as part of a larger framework that's more modern. So the point that I want to make very early in the course is that names for things are way less important than the nature of the actual thing. So if you are in a software organization that is using pair programming, that is using refactoring, that is using continuous integration, and you don't call it extreme programming, you are still using an agile methodology, and you are still using a kind of modern approach to software development. It doesn't matter what you call it. The fact that you are actually practicing the process is the thing that matters the most. So if we get down to kind of what comes after extreme programming, there are two very widely used frameworks for agile development that are still in widespread adoption, and those are Scrum and Kanban. And you have very likely heard of both of these things, again, kind of embroiled in this buzzword kind of situation. We're going to very briefly talk about each one of them. We're going to compare and contrast them, and then we're going to talk about sort of this false dichotomy between the two of them. So the entire concept of Scrum is to maximize communication between members of a team, and then at scale to maximize the communication between teams within an organization. And so the idea behind that is if you can maximize communication, that means you're going to be able to quickly mitigate any impediments and also any risks that are caused by changes that other members of the team or other teams in the organization aren't aware of yet. So basically what Scrum is trying to do is maximize transparency. It's trying to organizationally make sure that everybody that has access to the code is aware of any changes, is aware of any pitfalls or any roadblocks as early as possible to minimize the amount of time spent trying to overcome those impediments by multiple people. So a large component of Scrum is the daily Scrum meeting, in which each team member updates all the other team members on what they did the day before, what they're supposed to do that day, and any impediments they have that are keeping them from doing their job. This is really facilitated by what's called a Scrum Master, and the Scrum Master's job is to make sure that the Scrum meeting doesn't take half a day. It's really supposed to be maybe 3, maybe 4 minutes per person, and the Scrum Master should take all of the impediments away and kind of facilitate across Scrum groups to make sure that all of these impediments are dealt with in an efficient kind of way. Another key component of Scrum is the idea of organizing your development efforts into fixed length release cycles. Those cycles are typically called sprints. And so what will happen is you will have a sprint planning meeting in which you will pick, 2 dozen or 3 dozen items, depending on the size of your team, out of the backlog. You will schedule them for that sprint. You will assign them to people on your team. And then throughout that sprint, during your daily Scrum meetings, you will kind of communicate about your ability to do the tasks that you're assigned for that specific sprint. Kanban, on the other hand, is really geared toward minimizing the time it takes to take a project from conception to reality. So it's the idea of shrinking the time from an idea on paper to an actual implementation of software. So this is very similar to prototyping, if you want to think about it that way. What you want to do is you want to get functional code in the hands of a client or a pilot group at a client as quickly as possible. So one of the kind of markers or the key aspects of Kanban is what's called a Kanban board that has a whole bunch of swim lanes. And the idea is each task in a Kanban board is moved across the board through these swim lanes, each of which indicate how close to complete that task is. So on the very far left, the first swim lane might be something is in the backlog, and at the very far right, the swim lane might be the client has already signed off and has accepted this task is completely complete. And so what the Kanban board does is it allows you to see any bottlenecks, so places where tasks are piling up, and it's supposed to identify places where you can increase organizational efficiency and reduce the time it takes to get a specific task from the left-hand side of the board where nobody's really working on it to the right-hand side of the board where the client is totally happy with it and willing to pay for the work. So continuous deployment is also a key aspect of this framework, and the real reason is because if you don't have continuous deployment, then your client can't actually see the stuff that you are working on, and so the time it takes to deploy the code becomes the bottleneck. It becomes the amount of time you have to wait for the client to actually accept the next round of changes. So continuous deployment is a thing that we're going to talk about a little bit later in the class when we talk about application life cycle management. But I want to be clear that continuous deployment is different from continuous integration. It's sort of like an additional step. And basically what it's saying is not only do you continuously integrate your code across developers inside of a team, but you also continuously deploy that code to some sort of test environment where a client can get their hands on the latest and greatest changes, probably at a day, if not more frequent occurrence. So if you kind of line these things up and compare them side by side, really the differences become pretty stark. And so you might hear people use Scrum and Kanban interchangeably, which is absolutely incorrect. They have different ideologies, they have different concepts about what is really important. While Scrum really optimizes communication, Kanban really optimizes efficiency in a lot of ways, or throughput of the team. So these are definitely not the same thing, but there's also kind of a false dichotomy. Why don't we do both of these things? If we have the ability to optimize both communication and the throughput of the team, why wouldn't you do that? So there is this artificial concept that these are diametrically opposed things. Isn't necessarily true. It's also kind of dumb. And like we said previously, buzzwords are buzzwords, words are words. The processes are the things that we actually really care about. And so there is absolutely no reason why you can't have both swim lanes to track tasks and identify organizational bottlenecks. At the same time, you have daily meetings to understand why team members might have impediments on specific tasks. At the same time, there is absolutely no reason that you should have to wait until the end of a sprint to incorporate known requirements change. So anybody who is sort of a purist in either of these walks of life might have tons of ideological reasons behind why they are a purist. There are a lot of cases where pragmatically it is beneficial to not be a purist and kind of take a hybrid approach that maybe fits your needs a little bit more. So in a practical sense, what you need to do is you need to look at the project at hand, look at what is important to your client. Is it getting their hands on code, or is it transparency? Is it making sure that they understand what impediments are presented to the team? And if the client wants some mixture of Scrum and Kanban, even if a textbook definition says that you shouldn't be doing it, it makes no sense to tell them that you can't when you can fairly easily combine these two things. So I want to end with a concept that is also kind of thrown around a little bit haphazardly. The next video that I'm going to do, or the next lecture, is going to be specifically about software teams. And toward the end of the semester, we're going to extrapolate that a little bit and talk about organizations as groups of software teams. What you're going to find out through the next video and that subsequent discussion is that Scrum is great for 5 people or 6 people. When you get to 45 people, or you get to a dozen geographically dispersed Scrum units, it's extremely difficult to try to synchronize all of their impediments and synchronize all of their knowledge and communicate efficiently across time zones or across vast distances of space. And so there's this idea of scalable Scrum. And so suffice it to say that organizations the size of something like Microsoft or Amazon or Google have a really hard time using just sort of vanilla Scrum off the shelf. What they need is the ability to synchronize in a larger context between many different Scrum teams. So scalable Scrum is the idea of scaling up a small Scrum group. So you take the same sort of ideas of Scrum, but you kind of blow up the idea of a daily Scrum meeting into multiple Scrum meetings, and then meetings about those Scrum meetings that happen less frequently or asynchronously or over text communication through message boards, etc., etc. It's the idea of basically generalizing Scrum to a much larger group of people. So there are 3 or 4, but really increasingly 2 extremely widely accepted methodologies to scale Agile. These are known as LESS and SAFE. You likely have seen these if you have been on LinkedIn for more than about 5 or 6 minutes. These are certifications that you can receive through certification granting entities that have the exact same names. A lot of this is strictly around project management for software engineering. So it is even less the technical side and more the project management side of things, trying to make sure that you are optimizing your organization in such a way that you are mitigating risk that isn't necessarily technical in nature. It's really more based on communication between your organization and the client, or teams within your organization. And so we are going to talk about these methodologies for scaling Scrum specifically in the module on software organizations. It's closer to the end of the semester, but I wanted you to be aware of the kind of context. We have started with Waterfall. We've moved from Waterfall to this sort of more agile environment where we implement something like Scrum or like Kanban or some mixture of the two. But we also have to generalize that to very large international organizations, and LESS and SAFE are basically just 2 ways of doing that that have been well documented. So that wraps up our conversation about Agile methodologies and Agile software development. We're going to have one more video in this unit specifically about the different types of teams that you might see inside of a software organization, even small ones. And then that's going to wrap it up. So thank you very much for staying engaged, and I appreciate everybody's interest. Thanks again.